Let's do this. STAAR Review 1 from 2022. I will read the questions and highlight the keywords as I go. Number 1. The graph of the quadratic function r is shown on the grid. Which answer choice best represents the intercepts of the graph of r? Whenever we see a question mark, we read that sentence extra carefully. The keywords here is which answer choice best represents. So best represents, okay. The intercepts is the keyword. What are the x-intercepts? We have x-intercepts and we have y-intercepts. The x-intercepts always go with y equals to 0. So their coordinates going to have 0 for y, and the x-intercept goes on the x. The y-intercept always have x equals to 0. So their y-intercept point goes with 0, y-intercept. Okay, now just by knowing this, I can eliminate some answers. Let's look at answer A. The x-intercept is 5, 0. Now this one could be, because it follows this. The y-intercept is 0, 10, 0, -2. Okay, that could be the answer. Let's look at number B. The x-intercept has 0, -10 and 0, 2. That cannot be, because the 0 for the x-intercept should be on the y, and the y-intercept also, the 0 will have to be on the x. So that is not the answer. Next one, C. X-intercept is 0, 5, y-intercept 10, 0, -2, 0. The zeros are in the wrong place, so that cannot be. Number D, x-intercept -10, 0, 2, 0. Okay, the zeros are in the correct place. Y-intercept 0, -5. That could be it too. So it's between A and B. Now let's look at A a little more carefully. We have two y-intercepts, and we are given that this is a function. If it's a function, when it has two y-intercepts, then it's not going to pass the vertical line test. Plus we see that there is only one y-intercept here, so that is not the answer. This is for example a graph that has two y-intercepts. You see them here, two y-intercept, but it doesn't pass the vertical line test, so that's not a function. So this is not the correct answer. A is not the correct answer. The correct answer is D. Now here I was able to answer without even looking at the graph, but if we look at the graph, we also need to be able to take the points, because sometimes we're not going to be able to eliminate 3 out of 4 answers. So let's look at the x-intercept is here and here. What are their coordinates? We know for y we have 0 for both of them, and here we have -1 is the x-coordinate, that's the x-intercept, and here the coordinate is 2, so it's 2. What about the y-intercept? We know that the x-coordinate is 0 and y here is -5, so -5 goes on the y, and we see that our coordinates match the coordinates given here. Okay, let's go to the next one. A worker is packing items in boxes. The table shows the linear relationship. Linear is a key word. I know it's going to be a line, and the line means y equals mx plus b. So linear relationship between the number of items the worker has packed in box after different amounts of time. Okay, now let's look at the table. The table is a representation of a chart that has X on the left and Y on the right. If you forget, think of it as left, right. Think of the alphabet. Which one is first in the alphabet, left or right? Well, it's first the left. The same with X and Y. X is first. So if you forget which one goes to the left, which one goes to the right, it's the same order as in the alphabet. First the left, or first is X, which goes on the left, which is before the Y and the right in the alphabet. Okay, so this is the X on the left, and this is the Y. Good. Now we have our table. Okay, let's read. And here's the question mark in the next question. So this one I need to read it extra carefully, so I can I know what the question is. Which statement describes the rate of change? Oops, here is a keyword, rate of change. That means slope. In general, when we have slope in math, it can be given as a rate of change. That term is really from science mostly. We have also seen it as rise over run. And another way to see it is a number of something per a number of something, like miles per hour. That's a rate of change. That's a slope as well. Okay, so now we know what we need to find. We need to find the slope of the number of items of the workers parked in boxes with respect to the number of minutes of the worker has been packing items in box. So that means the slope of Y versus X. Okay. Now let's look at the answers. And let's see what we always read the answers just to see if we can immediately eliminate something, or to know what the options are. A worker packed 8 items in boxes per minute. Now let's see where we see this per here. It's in the answer, so that's another indication that we're talking about a slope. But what is the slope in A? It says 8 per minute. That means per 1 minute. 8, which the number that comes before the pair, is the rise. The number that comes after the pair is the run. So here the slope, this m that usually is called as m, that's equal to 8 over 1, meaning 8. Okay, this m here is also seen in the slope-intercept form of a line. This is the slope, just to remind you, and this b would be the y-intercept. Okay, what is the slope on the second? It's 37 items in boxes per 1 minute. That's just 37 over 1, which is 37. And here the other option is 4 items per minute. It's 4 per 1, which is 4. 15 items in boxes per minute. That's 15 per 1, which is just 15. Quick example here. What if I had like 12 items per 5 minutes? What would the slope be? Well, that would be 12 over 5. Okay? All right. Now, how am I going to solve this problem? The best is to utilize a graphing calculator, which is allowed, and I will have to take into account that that table here. Now this table has 4 points. To draw a line I need 2 points. The same goes with the slope, because the slope essentially is going to be representing a characteristic of that line. So 2 points are enough. I'm just going to find the 2 best points. A good point should not be a decimal, and if it's a decimal that is going forever, for example, if that was 0.33333, that goes forever, I will have to convert it into a fraction, otherwise I'm going to get it wrong. My graphing calculator will I will have to round it when I put it in the graphing calculator, and that would not be good. Now we know that 0.3333 is 1/3. If we forget, we go to the graphing calculator, and once we write 0.333333333 and keep going, eventually it's going to give me the option to convert it into a fraction. Is going to give me the 1/3. Okay. So here I'm just going to choose the points with the smaller numbers, just to not have to type too much and to not have to go too far away from the origin. The first is going to give me the point 5,20, and the second is going to give me the point 7,28. They're both good points. In other words, if I have an X and Y chart, I would have 5 going with 20 and 7 with 28. Okay, so let's put those, let's see how I'm going to solve this problem using the graphing calculator. First thing, I'm going to create a table. I'm going to hit the plus sign and then the table, and then I'm going to insert those numbers. 5 goes with X, 20 goes with the Y, 7 is for X, and 28 for Y. Now notice that the coordinates here are X1 and Y1. Then in the next line I'm going to write the following: Y Y1. Then I'm going to put a squiggly after I give it an extra space. Squiggly. Then M, X with subscript 1. Oops. Give it one more space. Oops. Plus B. The moment, if we write it with a squiggly, we're asking the calculator to estimate it. So the graphing calculator does the work. We also need to put X1 and Y1, because if we put X1 and Y1, we refer to the table we just did. Now we look at what's underneath at the bottom. It says M equals 4, B equals 0. Okay? M equals 4, we can write it somewhere on the side. M equals 4, B equals 0. That means that the equation that we were looking for, this one in the beginning, that represents this linear function, is the following: y equals 4x plus 0. Now the plus 0 doesn't offer anything, so we write it as y equals 4x. Also, I got this information that from this part, that the slope is 0, and if I wanted the y-intercept, that y-intercept would be 0. So the slope is 4, the y-intercept is 0. I look at my answers, and I see there is a 4, so this one would be the correct answer. go to the next one. Number 3. System of equations is graphed on the grid. Okay, I have 2 equations, and I see those. I immediately see that those equations are going to be linear because they're represented by lines, meaning each one of them is going to be of the form y equals mx plus b, is slope-intercept form. Now let's read the question. Which system of equations is best represented by the graph? Here's the question mark. I'm going to have to read it carefully. And the key word here is system of equations. Why system? Because we need 2 equations because we have 2 lines. Okay. Now, we can try to eliminate some answers. And if we can eliminate 3 out of 4, we're good. If we can't, then we're going to focus on this one so we don't have to type too much on the calculator. Now, when I have the line mx plus b, I know that this one is going to be the slope, and this one is going to be the y-intercept. B is going to be the y-intercept. Maybe the y-intercept would be good to eliminate any questions for starters, or maybe not. Maybe I won't be able to eliminate anything. For the y-intercept is -3 and -8. Now I see that all all the answers are of the form y equals mx plus b. So the y-intercept is basically what's at the end. In all of them is -3, -8, -3, -8, -8, -3. So I can't just on a first look eliminate. On the other hand, I see that the -3 goes with the increasing one, so this one is going to have a positive slope, and the -8 goes with the decreasing one. This one is going to have a negative slope. So -3, positive slope, -8, negative slope. Let's see if I can eliminate any answer so I don't put too much stuff on the graphing calculator. If I can't eliminate anything, you just have to put everything. And the idea is we put one by one the set of the equations on the graphing calculator and see which set has a graph that matches this one. Alright, let's see. -3 with a positive slope. Answer A. -3 goes with a negative slope, so that's not it. Let's look at B. -3 is with a positive slope, that works. -8 with a negative slope, that could be it. Let's look at C now. -3 goes with a negative slope, that's not it. And answer D. -3 goes with a positive slope, -8 with a negative slope, that could be it. So it's between B and D. Now if I want, I can use rise over run and figure out the slope and see which one it is, but I'm not gonna do it. Rise over run is good. Sometimes I may make a mistakes on the sign, so I'm just gonna plug in option B and then option D and see which one is going to be the correct one. Y equals 2/5x minus 3 and y equals -3/5x minus 8. That's going to be option B. Let's go to the graphing calculator and see what happens. Okay. Y equals 2/5 x minus 3. So we have one line here. Let's put the other one. Y equals -3/5 x minus 8. Let's see. It looks like this could be it. How can I be sure? Sometimes especially when the scale is different on each axis. Just because a graph looks the same as a given graph, that doesn't mean it's the same, or sometimes just because the graph looks different than the given graph, that doesn't mean it's not the same. The only way that you can guarantee that you got the correct answer is to check the coordinates. And we need 2 coordinates per line. So let's go with the top line, this one. We have that coordinate and that coordinate. Okay, what is the coordinate for this one? Is underneath -5, so x is -5, and next to -5. So it's -5, -5. What about this one? Well, the coordinates here would be, it's the y-intercept, so it's going to be 0 for x, and it's next to -3. So it's 0, -3. Okay, I only need 2 coordinates for the other line, if they are available. Sometimes they are not available, they are not like exactly, I have to estimate, and sometimes even just 1 point depending on what the other option shows could be enough. Here, it's the other y-intercept, which is also 0, -8. So I need those points to show on my graph. If they do, then that's the correct answer. Okay, -5, -5, 0, -3, 0, -8. How do I do that? I go to my graph and I tap those points. This is good. -5, -5, 0, -3, 0, -8. So the correct answer is B. So this is what I'm going to choose. Okay. Let's go to number 4. Which graph represents y as a function of x? Okay, we know that we can answer to this one utilizing the vertical line test. Let's see if the first one passes. It doesn't pass. I have 2 points. That's not a function. But what does it ask me? I forgot that we need to read the question carefully. Does it ask me for which one is a function or which one is not a function? Okay, here's the questioner. Which graph represents y as a function? Okay, so it needs to be a function. This one is not a function. That means that's not the answer. Same happens here. And that's not the answer. Next one, I have 3 points crossing. More than 1, more than 2. As long as it's more than 1 is enough. Option D is the one that remains, so that's the correct answer. I can double check. There is no way that I can cross by drawing vertical lines in more than 1 point at a time. So the correct answer would be D. Okay, next. Well, that question is very popular in STAAR test, but sometimes they're not going to give you a graph. Sometimes they're going to give you a table or a chart. So let's take x and y. Let's do a chart. What if it was 1, 2, 3, 2, 5, 6, 7, 6? Is that a function? We see that a repetition of 2. The rule is that you can have 2 same inputs that go to 2 different outputs. 2 same x coordinates that go to 2 different y coordinates. Here we have 2, I'm going to write this because it's important. 2 same inputs and no 2 same inputs to 2 different outputs. That's what we don't want. Okay, if that's what we got, that's not a function, so we don't want this. Here we have 2 same inputs that, do they go to 2 different outputs? No, they go to 2 same outputs. That means it's just a repetition. So this is a function. Now let's rewrite this and change this 6 to 8. What happens here? I have two same inputs that go to two different outputs. That is not a function. Okay. Now another way that they can give me the same question to determine if it's a function or not is if they give me a diagram. Here are the inputs, here are the outputs, or here are the x, here are the y, and its coordinate or its input is represented by a dot. Here's the set of inputs, the set of outputs. Okay, and then I'm gonna have arrows connecting those. Okay, that's a function. I don't have two same inputs going to two different outputs. What if it's this one? Is that a function? I have two same outputs. That's not a problem. That is a function. Now, what if I have that? I have two same inputs, because this is double, it has two arrows, going to two different outputs. That means this is not a function. Okay, so this is not going to be a function. They can give me either way, and they will be creative, but it's going to be along those lines. All right, what is number 5? What is the solution to this system of equations? And they're going to give me a system. Let's see, here's the question mark. What is the keyword? The keyword is solution. I also see that each one of those equations is linear. How do I know it's linear? Well, it doesn't have x squared, it doesn't have x cubed, it doesn't have 1 over x. That means it's linear. Okay, linear means each one of those is going to be represented by a line. Okay, now I'm going to read the answers to see what I should expect. The first one is giving me that the solution is 12,16. So for the A to be correct, if I graph those lines, they need to intersect at 12,16. That's the solution, the intersection point, because it belongs to both, it satisfies both, it solves both. Okay, how about the second one? For the second one, these lines need to intersect at 15,17.5. How about the third one? There is no solution. Here, no solution means no intersection. How about those lines? Do they intersect? It doesn't show that they intersect, but if I extend them, they will eventually intersect. So those lines need to not be able to intersect ever. Those have to be parallel lines. So no solution means parallel. How can I recognize parallel lines? If I can't tell from the graph whether they're parallel or not, means the same slope also algebraically. So I can recognize them even just by looking at the equation. Means same slope with one more detail, different y-intercept. Okay, those are parallel lines. For example, if you look at those two lines, they're parallel. You see, they have the same slope, the same rise over run, but they have different y-intercepts. Okay. How about the last one? There are an infinite number of solutions. So if this is one line, the other line needs to be on top of it. means it has infinite intersections because they are identical. So here they are parallel, here they are identical. How do I recognize identical algebraically? Well, they have the same slope and they will have the same y-intercept as well. Okay, obviously they will have everything the same. So how do I know which question it is? I will have to plug that system on the graphing calculator. And here's a complication. The STAAR testing graphing calculator is not going to graph that. Is not going to graph this because it's not in the format y equals. The first one, for example, is 2x plus y equals. It cannot graph that format. Our regular Desmos can graph it, but not the STAAR testing Desmos. So we have to convert it, each one of them, into a format y equals in order to graph it. Let's see how I do that. Start with the first one, 2x plus y equals 40. And let's put it over here. Okay, well, we want y equals, that means y needs to be isolated. So I'm going to have to get rid of I'm going to do the standard method for that. We do PEMDAS to the left, PEMDAS to the right, cross the bridge and isolate, a way to say it. Okay, there is no PEMDAS on the left or on the right. So crossing the bridge is with the 2x. So I put a negative 2x to cancel it, and then it will appear on the other side, and I can write it y equals negative 2x plus 40. Do I need to do anything else? No, because y is already isolated. I have the y equals. Now let's go to the next line. X minus 2y equals negative 20. X minus 2y equals negative 20. Okay, PEMDAS to the left, nothing to do. PEMDAS to the right, nothing to do. Cross the bridge, which one will cross? The x, not the y. So let's put negative x. What do I get? I get negative 2y equals negative x, negative 20. Now, it doesn't really matter if you write it negative x, negative 20, or negative 20, negative x, but I'm just going to put the x first. Then, what's the method? PEMDAS to the left, PEMDAS to the right, cross the bridge. Now isolate, the last step. Y needs to be by itself. I have to divide by negative 2. The left and the entire right hand side. The entire right hand side. Okay, so let's do this. So what do I get? I get y equals, which is what I want, big fraction line, negative x, negative 20 over negative 2. That's what I want. I can potentially simplify this, but that's not a problem. The graphing calculator is going to graph it, and no matter if I simplify it or not, it's going to be the same graph. So I'm not going to take the risk of making a mistake when simplifying. Okay, so now that I got the equivalent functions, I'm gonna go to the graphing calculator and put those functions and see what the solution is. If it looks like an x, there's going to be one solution. If it looks like a parallel lines, it's going to be no solution, and if it looks like one on top of the others, they're going to be identical. Now, before I even put that, I could tell if they're parallel or not, or identical or not, but to do that I would have to simplify this one. Potentially you can see that those are going to go together, and it's going to the slope is going to be 1/2 versus negative 2, so they're not going to be parallel. Turns out that they're going to be actually perpendicular, because the slope of one is the negative reciprocal of the other. But let's see those on the graphing calculator, since it's good to be able to know this stuff just to eliminate answers at the end of the day, confirm everything on the graphing calculator, and if you can't eliminate, still use the graphing calculator. Okay, so let's do here the first one. Y equals negative 2x plus 40, and the second one is y equals fraction line negative x negative 20 over negative 2. Let's see where that is now, and it looks like that. It's an x, so it has one solution, and the coordinates of the solution are 12,16. Do I have a 12,16? I have a 12,16, and this is the first one. Okay, now potentially, if I didn't have a graphing calculator, I could plug in the equation and see that those will satisfy both equations, but I wouldn't have a way to test well, it would be difficult to distinguish, to test for that or that. So when we have a graphing calculator, it's let's utilize it. Now, if I wanted to do without a calculator at all, then I would actually have to solve the system by substitution or elimination or something, which we don't have to do here. Okay. Let's go this one. Here we have a question mark, so let's read it. Which graph best represents a quadratic function with a range? Okay, here's a keyword, range, of all real numbers greater than or equal to, and then I have a key number. Now, let's see what those questions are very frequent. They involve domain and range. We have domain. The symbol is D. Range. The symbol is R. I have to remember that domains goes with X, is the set of all inputs. Domain goes with X, that's the set of all inputs, and range goes with Y, that's the set of all outputs. Here's the inputs, and here are all the outputs. Alright, how do I remember that D goes with X, R goes with Y, and that X is the input and Y is the output? How do I remember that? Again, you can use the alphabet trick. Whichever is first in the alphabet goes with the corresponding letter that goes first. For example, D is before R in the alphabet, X is before Y, and I is before O. All of those that go together, and they are before the corresponding letter. So that's a way to remember it. Okay, here we want the range. Range means Y. So Y greater than or equal to, greater than means the opening goes to Y because that's greater. The big opening, the small opening goes to the smaller, or equal to 3. Okay, this is what we want to check, and there is a number 3. Let's look at the answers now. See if I can eliminate any answers just by looking at the numbers. The answers that don't have the 3 explicitly will have to be eliminated, and the 3 needs to be on the y-axis. Now, normally when you have a quadratic, the range starts basically from the vertex and can either go up or starts from the vertex and it goes down. So here I'm going to look at the vertex that goes to -3. I don't have a -3, I have a 3, so it's not A. Okay. Now B, the vertex starts at 3, and of course then it goes down. The range goes from 3 and down. That could be it. I will check it in a little bit. C starts at -3 and then the range go up. I don't have a -3, so it's not C. What about D? The range will start at 3 and go up. Okay, so which one it is now? Oops. Which one it is? It's greater than or equal to 3. Oh, didn't save those, so let's repeat that. That's from -3 and down. We didn't want that. And that's from 3 and down. And that's from -3 and up. We don't want that. And that's from 3 and up. Now what we got is -3 and up. What we got is that y is greater than or equal to 3, so it's 3 and up, and the correct answer should be D. What if they ask me about the domain of this function? What would the domain be? Find the domain. Basically project on the x-axis, on the horizontal axis, and if we project, we see that we cover everything. Now don't stop here because that keeps going, so as it keeps going you project and you cover the entire x-axis from -infinity to infinity. That means the domain would be all real numbers, because if you cover the entire x-axis you have all real numbers there. Okay, and just to give you a little visual representation, to find the range, basically you project on the y-axis, and if you project, we see that you start from the top, which is the vertex, and down. Here you start from the top and from the bottom, and you go up, and so on. Okay, let's go to the next one. Number 7, the value of y is directly proportional to the value of x. Here is a key word, directly proportional. That means the equation is y equals mx. It doesn't have b because b is 0, so we don't even write it. Directly proportional means just y equals mx. It's not mx plus b. When x is 12, when x is 512, and then y equals 128. What's that? This is the chart. 512, 128. What is the value of y when x is 64? So when x is 64, what is the y? And we have 4 options. Those are the numbers that would go in this question mark. Okay, how do I solve this problem? There are many ways to do it. Here I'm going to utilize the graphing calculator, and let's do that. Okay, so I'm going to hit the plus sign, table, and I'm going to make the table that I got is 512 on the left, 128 on the right. Now at the next, I'm going to put y1 and squiggly, m x subscript 1, and that's it. It's gonna give me that the slope is 0.25. Why do I need this? Because if I know the slope, then I know that my equation is y equals, actually before that, I don't like the decimals. Usually they're not gonna give me any options with decimals, and I have to make sure that I can convert it to a fraction. So of course I know that 0.25 is a quarter, like 25 cents is a quarter, and 0.25 being a quarter is going to be equal to 1 over 4, but let's see how I can utilize the graphing calculator for that. I hit the fraction sign. It's going to give me the 1 quarter. So now that I know the slope, I know the equation, and the equation is y equals 1 over 4 x. And when I know the equation, I can get the table. So I'm going to hit the wheel, then the table, and it's going to give me a table. I don't need those values, so to avoid confusion, I'm going to get rid of them. What I need is the 64, but let's make sure that the values that I got are correct. So 5, 1, 12 will give you 128. 128 is going to show by itself. Same way, when I put 64, it's going to give me the y that goes with it, and which is 16, and that's the answer. Now let's see if I got 16. Yes, so 16 is on the third answer, so here's going to be C. I'm going to make a quick comment here. Looking at the graphing calculator, I see it's a line. And looking at the table, the top table, I only had 1 point. So how was I able to define a line with just 1 point? That's because remember that includes that the y-intercept is 0. That's another point, and you see that it goes through the 0, 0 point. If you want to see it, I'll type it here. 0, comma 0. You see that 0, 0 point? That is included because I gave it y equals mx, so it's like I gave it another point. If I want, I can also put it here, 0 and 0, and nothing will change. Okay, so it's like the moment you write y equals ax, you gave 1 point, the origin, and then 1 more point based on your data, and that's why we have the 2 points that we need to do the graph. Now let's go to number 8. Customer is buying bath towels and hand towels and can spend no more than, that's a key word, no more than $100. No more means either less than or equal to 100. Each bath towel costs 8 and each hand towel costs 5. So here I would have 8, which came first with the x, plus 5 with the y, less than or equal to 100. That would be the equation. Now, at the same time, in this problem gives me the equation 8x plus 5y less than 100. So I wouldn't have to think really hard what the equation is, but there could be another problem that doesn't give me the equation, and then I would have to think what doesn't give me the inequality, and then I would have to think what the inequality is. So it's good to know how that's related. Okay, represent all possible combinations of x, the number of bath towels, and y, the number of hand towels. And, okay, now let's see. Here's the question. What is it asking me? Which graph best represents the solution set of this inequality? So best represents, so which one is the solution, not which one is not the solution. And the solution set. The solution set is because every time we have an inequality, we have many solutions. For example, and those solutions, if that represent the inequality, are usually indicated by shading the area that they live. Any point here on this shaded area, for example, would be a solution. Now, if the line is solid, all the points on the line are solutions. On the other hand, if the line is dashed, then the points on the line are not considered as solution. So this is how this is what it means, the solution set. We need to have a shaded area. Okay, now the temptation is to just go to each one of those graphs and look at which one is greater, less than, or equal, and that would be the wrong way of doing it, because that question is very tricky. The problem is it's not, the y is not isolated, so I don't trust that. For example, less than would mean if I have a graph like this, I would shade the bottom part. At the same time, that is not to be trusted, because if there is a chance trying to isolate the y, this is going to flip, and instead of less than, I will have greater than. Now let's see how I would isolate y, and in which case the inequality flips. Okay, 8x plus 5y. 8x plus 5y less than or equal to 100. Okay, so bottom line, if I want to graph it, like if I cannot eliminate 3 out of 4 without graphing it, I need to have the y isolated. And in order to eliminate correctly the 3 out of 4, if it's possible, or anything out of 4, any number out of 4, the y needs to be isolated. Otherwise, don't trust the inequality. How do I isolate the y? Same method. PEMDAS to the left, nothing to do. PEMDAS to the right, here nothing to do. Cross the bridge, the 8x needs to go. So negative 8x. When you subtract or add, the inequality remains the same. So the inequality here would be, let's put it on the side, 5y less than or equal to negative 8x plus 100. Okay. Now let's isolate the y. We would have to divide by 5. Now here is the trick. Here's the tricky point. If that 5y was negative 5y, then you would divide by negative 5, and the moment you divide by negative 5, you would have to flip the inequality. So it would become, from less than would become greater than. And here is the point that you need to double check, otherwise you'll give the wrong answer. Of course, here we divide by a positive, so it doesn't make any difference. And what I get is that y isolated is less than or equal to negative 8x plus 100 divided by 5. Okay, so now that I have this, I can trust the inequality, and I can utilize it to see if I can eliminate anything. If I can't eliminate 3 out of 4, then I will have to actually put it on the graphing calculator and graph it, and I may just do it afterwards just to see, but I'll see if I can eliminate anything. Bottom line, it's less than or equal. Okay, now let's go and check one by one those graphs. Let's look at A. The shaded part is above, and there is a dotted line, so that would be a y greater than, not equal, y greater than something. I have y less than or equal, so that's not it. So I eliminated A. How about this one, B? The shaded part is below, and there is a solid line. Okay, that is y. Below means less than. The solid line means equal. That could be it. Let's do C. The shaded part is above, solid line. Oops. Solid line, that means y is greater than or equal to something. That's not it. And D, I shade below dotted line. That means y is less than. That's not it. It needs to be less than or equal to. So I have eliminated 3 out of 4. The correct answer is B. Now, there could be a question that there are 2 answers remaining. Like I can only eliminate 2 out of 4. What would I do in this case? In this case, I would go to the graphing calculator and I would have to graph it. Here, and if I try to graph this one, it's not gonna graph it. My regular Desmos will, but a regular the STAAR testing calculator is not gonna do. But it will be able to graph this one. And this one is what you need to plug in on the calculator. Y less than or equal negative 8x plus 100 over 5. Now, our calculator is not going to graph the less than. That we will have to figure out which part is to be shaded. So no matter what that is, no matter if it's less than or equal, greater than or equal, less than, greater than, it doesn't matter what it is. What you're going to plug in is y equals the right hand side. That's what you're going to plug in on the calculator. So here we're going to plug in y equals fraction line negative 8x plus 100, and the denominator is a 5. And I get this one, and suppose I have 2 answers. How will I figure this out? First, you can look at the shape, and at first glance, it looks like the answer that I have chosen as correct is wider, and the answer that I'm getting on the calculator is more narrow or taller or something. Now, that doesn't mean much. It may be that the scale is different. And I see that the scale is kind of different. You see the y and the x is different here. The x goes up to 14, almost 14. The other one goes up to 28. So it's a different scale. Okay. How do I make sure? Well, I have to find 2 points, 2 good points. The intercepts, if they can be defined, are good points. When I say good points, they need to correspond to intersections of divisions. Now that's a good point here. It's the y-intercept, so x is 0 and 24y. That point here is not very good because it's not exactly, but I can tell that the coordinates, since the x-intercept is going to be 0, 12 plus. It's going to be a little bigger than 12, less than 13. Let's see if we got something like that in our Desmos. We got the 0, 20, and we got the 12.5, 0. Okay. Oops, I think I wrote this the wrong way, because the x-intercept has the 0 on the y, so it should be 12 plus, 0. Turns out it's exactly 12.5. Okay. Just to make a comment here, because you will make careless mistakes, like the mistake that I made here, putting the 0 in the wrong place. It's good to, at the end, go over your answers just really quick. Those careless mistakes, they're just gonna pop out really loud when you do a quick look at the end, preferably at the end of the test and at the end of the exercise. but always confirm. Even if you are 100%, just confirm, because it's going to show little careless mistakes. Anyway, we see that it doesn't look the same, but this is the correct answer. It has the correct points. It just has the different scale between the Desmos and the graph given. That's why it looks different. Number 9. An exponential function is graphed on the grid. Which function is best represented by the graph? Here I can try to eliminate answers, and if I can't, I'll have to plug in one by one and compare to the graph given. If I have good points, I can tap them to make sure that it's the one that I think it is. If I don't have good points, at least I need to arrange the scale of Desmos to be the same as the scale of the graph given, so the comparison is valid. But here let's try to eliminate as many as we can. And let's read it carefully. An exponential function. Okay, this is exponential. It's not quadratic. It's not linear. Which function best represented by the graph? So we basically want to find the function that goes with the graph. Let's look at the answers. P of x is this to the x. P of x is 2 times that to the x. P of x is this other thing to the x, and P of x is something else to the x. In general, that tells me that the exponential functions that we'll be considering here have this form: y equals a times b to the x. Now this b is the base, is the growth factor. Let's just put synonyms for that: base or growth factor, and any other along those lines. The mathematical term is base, but it can be called different equivalent names based on the application. Okay, now what do I know about that? When the base is greater than 1, that means increase. When the base is less than 1, that means decrease. And when a, and what is that a? That a is, on applications, the initial value, or whatever synonym would be for that: initial value, initial investment, anything. And on the graph is the y-intercept. Okay, now I can look the graph a little bit more carefully now. First of all, what is the capital A? It's the y-intercept. So what is the y-intercept? Is 1. So I know that A is going to be equal to 1. On the other hand, what is it? Is it increase or decrease? How can I tell? Well, I will have to go from left to right. So going from left to right. And why do I go from left to right? It's the same way that we write. We write from left to right. This is how we also read the graphs. So going from left to right, does it look like I go down or like I go up? And I see that going from left to right is like I go down. That's decreasing. So I see it's decreasing. What does this mean? That means we have, in this case, b is going to be less than 1. Okay, with this information I can hopefully eliminate some of the answers. Okay, let's look at the, I'm going to start from the bottom on this one. Okay, let's look at D. It's 25 to the x. That means b is 25, which is greater than 1. I want less than 1, so that's not it. Let's look at the other one. 1.25. Here b is 1.25, which is greater than 1. That's not it. Let's look at b now. I see that b is 0.5, which is less than 1. That's okay. That works. Let's look at A. A is 2. I want A to be 1. This is not 1, so that's not good. So let's eliminate. So automatically, by elimination, the correct answer is A. Now let's double check. We see that B is 0.25, which is less than 1. That checks. And then I have nothing in front of it. So A is, so it's like there is a 1 times. That means A is 1. So that checks too. Now that I have narrowed down, I can confirm, and we should always confirm. It takes seconds, and it can save me from careless mistakes that I know, but I mistyped or something, or misread or anything. So here, let's plug it in. You can write P of x, but you can also just, for short, you can put y equals, and that was 0.25 to the x. And we'll see that it kind of looks like what I want it to look. It's decrease, it goes through 1, and I'm not going to go in any further details. I'm happy with it. Let's move on. Which expression is equivalent to that? Okay, here's the question, and the key word is equivalent. For two expressions to be equivalent, they need to have the same graph. So what am I going to do? I'm going to do the graph of this one, then the graph of this, whichever two have the same graph are the equivalent ones, and it's going to be one is going to be the one given, and either A, B, C, or D. Okay, let's do that. Here I'm going to have some surprises when it comes to utilizing the graphing calculator. So it's n minus 4 and 2n plus 7, and I'm going to start with the one by one those options. Let me write those down so I don't have to go back and forth. Okay, let's go here, and I'm going to write the first one. Here I'm going to have the first surprise, because when I write it, and that's n minus 4 closing parenthesis, opening parenthesis, 2n plus 7 closing parenthesis. When I do that, I don't see any graph. Well, what is going on here? Why is there no graph? In that case, I know the answer, but let's see what the information. When you see that triangle, it says try adding y equals to the beginning of the equation. That's because it doesn't understand what I'm trying to do. It doesn't understand that I want to graph it, because it doesn't have the y equals. So you have to put y equals, and then it's going to graph it. Okay, and here you can arrange the scale so you see the graph a bit more clearly, meaning you can put your fingers on an axis and you can squeeze it or stretch it, the same thing horizontally or vertically. There is a loophole here. If you didn't want to write the y, you would have to replace, you would have to replace the n with x. Then even if there was no y, it would recognize what you wanted to do, and it would still graph it. But it's not the best idea to change characters, because you may make a careless mistake. So I would leave it as n, and add the y equals. Also, the correct mathematical way of writing is with y equals, so we might as well just write it correctly, because when we write it correctly, it's going to make more sense to our brain, who has seen this stuff before and still learns math. So it's good to give proper mathematical grammar to our brain. Okay, so this is the grammar of math, the way we write. Okay, this is the first equation. Now let's go back, because we may be able to just eliminate some of them. In general, two equations that they are not of the same order, they're not going to have the same graph. Now, what is the order? The order is the maximum power of x, or the input. Here the input is n. What is the maximum power of this equation? Well, if you distribute, you see that n is going to hit that n, and you're going to get 2n squared. The maximum power is squared. Look at a. The maximum power is 1. That's n to the first power. That's why we don't write it. So automatically it's not going to be n. I can plug it in to confirm, but it's not going to be n, because this is linear and this is quadratic, meaning the shape of this graph is going to be a line. The shape of this graph is going to be a U. It's quadratic. So we know that it's not going to be A. Same way it's not going to be B. So essentially it's between C and D. I can plug in the first option just to be convinced. Y equals 3 n plus 3. And you see it's a line. There's no way that a line is equivalent to a U shape. So that's not going to be it. So I'm not even going to plug in the second one. But I will do the third one, which is y equals 2n squared minus 15n minus 28. They're not the same, okay? So what about the last one? Y equals 2n squared minus n minus 28, and those are the same one. You can switch it on or off to see that they actually cover the same graph. Okay, so the correct answer is the last one. Okay, all right. And I could have eliminated the first two like right away. Okay, now let's move on. Now, if you don't have a graphing calculator, there are ways to do it still. I would have to take this one and distribute, and then it will look like that. Okay. Which situation shows causation? Causation means that there are two events. One of them is the cause, and the other one is the effect. Okay, they just want to see if I can read correctly. Let's start from the bottom. When the number of bike trails in a city decreases, the amount of rainfall in the city increases. Now the bike trails and the rainfall, it's probably not going to be related. It's going to be some extreme cases to be able to affect the weather by bike trails, maybe in some I don't know what sort of city that would be and how they would build those trails, but it doesn't look likely, so that's not it. When the amount of discount for sale increases, so what decreases? The discount increases, meaning the prices go down, the number of items sold during the sale decrease. So when the prices go down, the sales should increase, not decrease. So that's not it. When the number of hours worked each week by an hourly employee decreases, the amount of money earned by the employee also decreases. That's possible because you work less number of hours, you make less money. So that would probably be in, but let's read the top one just to see. When the number of people in a bus increases, the number of animals in the zoo also increases. That doesn't look like there is any relation. So the correct answer is B. Okay, let's go to number 12. A system of linear equations. That is a key word. Linear equation means y equals mx plus b, where m is the slope, b is the y-intercept, by a line h and a line j. The table representing some points of the line h. So this is for the line h, and the graph of the line j are shown. So, and this is the line j. Now, how are we going to solve it? First of all, let's see what the question is. Which system of the equation is best represented by lines h and z? That's the question. So which system? We have a system of equations. So in this system, they're going to be both equations. Is best represented. It's not asking for the solution to the system. It's just asking if ask me to write the two equations correctly, and I need to write both of them correctly, not just one of them. Okay, so I need to write both of them correctly. Now, there are a couple of ways to do it utilizing the graphing calculator. One way is to go one by one, write all of these options one by one, put it on the graphing calculator. For the one of them, try to do the table, let the graphing calculator do a table and see if it matches this table, and the other one, do the graph and see if it matches this graph. At the same time, it doesn't tell me which one is H. Maybe this is H, this is J, or maybe this is J and this is H. So it's going to be a lot of work if you don't have another option. This is what you're going to do. You plug option one by one, and you're gonna find the table and the graph for each one and see if you can match it. To minimize the work, we're not gonna do it this way. We're gonna go to the graphing calculator, we're gonna plug in the table, and we're gonna get the line, and then we're gonna plug in this graph and we're gonna get the line. In this table here, now how many points do we need for a line? Do we need 1, 2, 3, 4 points? No, we only need 2. So if you remember that, you just have to plug in 2. If you don't remember, just plug in everything. You're not going to make a mistake. But they are written horizontally. It's best to convert it to the vertical case as I know it better. X is at the top. And I'm going to take the smaller numbers. The smaller numbers are these ones in the middle. So I'm going to take X is negative 8. Now what is Y? Negative 8 goes with 1. Y is 1. And negative 4 goes with negative 2. So I'm going to write it like that on my graphing calculator. Let me take a note here. Negative 8, 1. Negative 4, negative 2. Okay, and then what about the other graph though? What is how am I gonna how am I gonna find the equation of the other one? Well, it has 2 points here. They're highlighted. That means those are good points that I'm allowed to use, and I'm allowed to consider that they are exactly at the intersections. Those points are the negative 4, because that's right above negative 4, and next to 6. So it's negative 4, 6, and this point is the 4 for x coordinate, and negative 4 for y coordinate. and that's all I need. Two points. Let's put here. The first one is -4 goes with 6, and the other one 4 goes with -4. Okay, so I have this one going with put a note here, -4 6 4 -4. All right, let's do this. How am I gonna do that? I will first of all hit the plus sign table. Let's put the first table, and that's -8 goes with 1, and then I have -4 going with -2. All right, what's the equation? I'm going to let the graphing calculator figure it out. So y subscript 1, 1 space squiggly, and then mx plus b, only it needs to be written as mx subscript 1 space plus b. Okay, and that is going to give me the m and the b. Now m is a fraction, is a decimal, and I want it as a fraction. I also, if I look at the answers as a fraction. So what is that as a fraction? 0.75. I advise you to always put the 0 in front of the point, because it just just saying 0.5 is not, is the way we speak sometimes, but this is not the proper way to write math. So hit the fraction, and that's -3/4. So the first line would be y equals mx plus b, that's -3/4 space x plus b is plus -5, so it's just -5. Okay, this is the first equation. Now let's do the second. Sometimes just one equation is enough, so I'm going to check and see, have I figured out the answer already, or do I need to do the second one? So let's check. Okay, I have found that the first line is y equals -3/4 -5. Oh, -3/4x -5. They have -3/4 -3/4. I have it only in only one spot. So now I know that this is the correct answer. But I'll do the other one just because sometimes you may have two options, and then you'll need the other line too. Okay. So the other line has this table. So I'm going to do that table, -4 6 4 -4. How do I do? I go here, plus, and I'm going to put a new, where was I? Here, plus, and I'm going to do a table. And here you notice that it's x2, y2. And I'll put -4. That goes with 6. Then I'll put 4, which goes with -4. And now how do I figure out this equation? Same deal. Y subscript, you don't put 1 now, you have to put 2, because this is the y2 that's on the table. Space squiggly, then we have m x subscript 2 space plus b. If I do this, it's gonna give me the slope and the y-intercept, which is the m and the b. It's a decimal. I'm gonna convert it into a fraction, negative 1.25. Hit the fraction, and this is negative 5/4. So the equation that I got is y equals, m is negative 5/4, so I'm going to put negative 5/4 space x and plus b, so that's plus 1. Okay, so let's write it down. It's y equals negative 5/4x plus 1. This is the other equation, and this goes with this one. Y equals negative 5/4x plus 1. We have already figured out is d, and without using the other. But in other cases, you have to have both of them if there are more than one that survive after you sort of eliminate. And we see that that corresponds to the other answer, to the other equation. So that's 100% correct. Okay. 13. Which answer choice described how the graph f of x is equal to x squared was transformed to create the graph x squared minus 1? Now here I can use a graphing calculator, but I should also be able to do it without it. Okay, so what's the key word here? This one is transformed to that one, so goes this way. That's first and that's second. Okay, from this one I get this one. That's the key word to know what they're asking you to do. Okay, so how do you what does that mean? That means this is this is in a sense your parent function, and this is the transformed function. If you compare the transform to the parent function, you see that the difference is the negative 1. This negative 1 is not associated to the x because it's not in the parenthesis. It would be if it was x minus 1 in a parenthesis square, that would be associated with the x, then that would be a horizontal transformation. Because it's not, it's a vertical. Vertical transformations follow common sense, horizontal not. For example, if it was x minus 1 squared, you would have to move to the right. Even though it's negative, you don't go to the left, you go to the right. But vertical transformations, horizontal go against common sense, but vertical follow common sense. So this negative 1 is you're just gonna go down, 1 unit down. Okay. So without doing using the graphing calculator, we can answer to this one. Let's see what A is. A is a vertical, and we know it's going down, so it's going to vertical, but it's going to go up, so that's not it. Horizontal, the moment you see horizontal, you know that this is wrong because what you got here is vertical. A vertical shift down, that looks correct. Just let's read the next one just to make sure. A horizontal when it's not horizontal, no matter what it says after that. How can I make sure? Now I'm going to go to the graphing calculator, and I'm going to do that just to make sure that what I got is right. And if I forget how to do transformations and I can't answer utilizing my knowledge, I can just put on the graph. Now, I'm not going to put g of x or f of x or whatever it says there. I'm just going to put y equals x squared. This is the parent function. That's from going to y equals x squared minus 1. It goes to this one. Okay, where is that one? Why can I not see? Oh, I'm too much zoomed in. Now let's zoom out. I was too much zoomed out. Let's zoom in, and I see that the blue one, which is the one that you're going to, is farther down, and it's exactly 1 unit below. So you can tell just from this picture that going from the white one to the blue one, you have to go down vertically. Up down means vertical, left right means horizontal. So let's write that too. When it comes to vertical, that means up down. Horizontal, that means left right. How do I remember that? Well, think of the horizon. The horizon is kind of horizontal, left right. Okay. All right, so that was it. Number 14, the expression d squared minus d minus 6 can be written in factor form as, let me change the color, as that. Okay, that's the factor form of this standard form. The names may not matter, but I'm going to write it. This is the standard form of a quadratic. This is the factor form, where k represents a number. What is the value of k? Record your answer. Record your answer and fill in the bubbles on your answer document. Be sure to use the correct answer. So here is not going to give me options. I just need to write somewhere that k is equal to what? Whatever that is. There are ways of doing it with or without a calculator, and here I get a graphing calculator, so I'm gonna utilize it as much as I can. At the same time, I will need to know some theory, and some theory, some formula. What is that? First of all, I need to know that the standard form looks like that. Y equals ax squared plus bx plus c. This is the standard form. And the factor form looks like that. Y equals a x minus x1, x minus x2. Where those x1 and x2 are the x-intercepts. What happens is that if the x-intercepts exist, then a factor form exists. If the x-intercepts don't exist, then you can't plug in anything here, so the factor form does not exist. If the x-intercepts are if there is only one x-intercept, then you write it like that: x minus x1, x minus x1. And sometimes, so in general, it follows this pattern here. And sometimes you can distribute the a to the first parenthesis, or you can distribute the a to the second parenthesis. All right, so this is the theory that I need to know. And in general, there will be questions that factoring will be important, but I have a graphing calculator, and I can find the x-intercepts in the graphing calculator, and then all I have to do is plug it in for x2, for x1, and this a is the same a as the standard form. So let's see how that's going to work in this case. Before I do that, though, I'm going to give you some pictures. When you have two different x-intercepts like x1 and x2, it's going to look like that. This one is going to be your x1 and this one is going to be your x2. When you have one x-intercept, is going to just touch the x here. No, I didn't draw it nicely, so it just touches. Then you have x1, which is the same as x2. And sometimes it doesn't touch the x-axis. Here is no x-intercepts. Okay, so those are the pictures. But let's see how I'm going to do that. First of all, I'm going to plug in this one on the graphing calculator, and I see it's with d squared minus d minus 6, and I will write it exactly like that to avoid making a mistake. And if I write it like that, I will also see d squared minus d minus 6. If I do it like that, I will also see that it's not going to graph it. It's because there is no y equals. If I forget, tap the triangle and it's going to tell you what to do. But in general, that would be the reason why it doesn't graph it. It's because you have to write the right, you have to put the right format, so everybody can read it, including the graphing calculator. All right, I did that. Now I can find the x-intercepts. It's -2 and 3. What does that mean? If I go back here, this one, I have this case, and x1 is -2, x2 is 3. They could be both negative, they could be both positive. They could be one negative, one positive, it doesn't matter. But now I know what the factor form is. It's going to be this one. A, what do I put for A? Well, what is my A, B, and C? I'll figure it out in a little bit, but I know based on those x-intercepts, we're going to have x minus x1 is -2, so it's minus minus 2. X minus and x2 is 3. Okay, I know that, but what is A here? What do I put for A? Let's compare the given standard form with the general standard form. A is whatever is in front of the x squared. We don't have x squared here, we have d squared, but that's the same. What's in front of d squared? It's 1. It's nothing. When it's nothing, it's implied that you have multiplied by 1. So I put 1 here. And then let's write it a little nicer. Y equals 1 times something doesn't change it, the times 1, so I'm not going to write the 1. Then I have negative times a negative, which is positive. Then I have the x minus 3. Now this is the factor form. If I compare it with this one, I say that what k has to be is -3. Okay, so this is how we do this one. Okay, see what 15 is. The graph of the linear function is shown on the grid. Okay, we have a linear function and there are 2 points highlighted. Linear is important. That tells me it's a line. I also see it's a line, but in case it wasn't clear, that's a line. I also have highlighted those points, meaning those points have good coordinates. That's why they indicate it to me. Like I can trust my eyes that it seems like it crosses at the intersection of those divisions. That's trust your eyes. This is the x-intercept. X-intercept means y is 0 and it's at 4, so the x-intercept is 4. Now this point here, it's not the x-intercept. What is the x-coordinate? The x-coordinate you can find if I project on the x-axis. Looks like it's 8. And the y-coordinate you find if you project on the y-axis, looks like it's -7. So I have 8 and -7. So I have 2 points. Okay, that's good. That means I can find the line. can find the equation for the line. Now let's see what the questions are. Which equation is best represented by this graph? Well, sometimes there is a chance that you can eliminate 3 out of 4 without even looking. Let's see if we can eliminate anything. We know for sure that a linear is going to be y equals mx plus b. M is the slope, b is the y-intercept. Here I see that the y-intercept it goes by 1 here, so 1, 2, 4, 6, 7. So the y-intercept is 7. Alright, I can eliminate those that they don't have 7 as the y-intercept. So A has to go, C has to go. It's either B or C. Can I eliminate any of them? Well, I can utilize the slope. I see that going from left to right, the same way that we write, I'm going down. So the slope will have to be negative. I know that the slope is negative, less than 0. But if I look at the surviving answers, the slope is negative to both. So I can't eliminate. I actually need to either find the slope or just find the equation. So I'm just going to find the equation. To find the equation, I need the chart. Here is the chart. It will have 4, 0, and 8, negative 7. And that chart is going to give me the equation. Let's go to the graphing calculator. How do I do? Plus table. I have 4 with 0, and then I have 8 going with negative 7. Next, the usual y 1 squiggly, m x subscript 1 plus b and I have the equation. I see that the m is a decimal, negative 1.75. Let's convert it into a fraction. Now 75 is 3/4, okay, and 1 is 4/4. So I have 4 plus 3, negative 7/4, which is negative 7/4. But I'm gonna double check because I may be making a mistake. Negative 1.75. Let's convert it to a fraction. And it's negative 7/4. Okay. Let's go back. So the equation will have m equals negative 1.75 and b would be equal to 7. Remember that b is the y-intercept, is the same as the 7 that we expected, so that's a good sign because we expected that it crosses 7. Okay, what's the equation now? Let's write it y equals mx plus b, but m was equal to negative 7/4x plus 7. Let me double check here. I can put the equation down now just to make sure, even though the graph is already there. I'm going to write it again with the fraction just to see it written nicely. Negative 7/4 times x and then plus 7. Of course, it's going to be the same graph as the one that I got. So if I eliminate this, my graph will appear. Okay. Now let's see if I have this option here. Negative 7/4. It's not this one. Okay. The answer is that one, negative 7 over 4x plus 7. And let's see if the graph looks the same. It doesn't look the same. Let's go home. Now if you tap the home button, now you see it's on the top right. If you tap it, then it's gonna kinda fix the scale for you, and then it's gonna be the same scale on the horizontal and vertical axis, and then it's gonna look similar to this one, because also here we have the same scale on the horizontal and decimal, meaning each division counts for 1 for both. I think I'm gonna stop now, and I'm gonna save the rest for the next video, just because it's getting too long, and if anything has gone wrong with the recording, I may need to know now so I don't keep going. But I'll continue with the rest of